Very good evening, sir.
Good evening. Good evening. Please switch on your videos. Please switch on your videos. Welcome to the class.
Good evening, sir.
Thank you. Thank you.
Good evening, sir.
Good evening. Good evening. Good evening. Very nice. Vishnukant, Dinesh, Ashwarya, Shubham, please switch on your videos. It looks very nice to talk to real faces.
Good evening, sir.
Good evening. Good evening. अनुपमा, आप भी अपना वीडियो ऑन करो. उत्कर्षा, प्रजक्ता, प्रणामी, Manash, please do that. All right. Now, I will request all the others to do that. Shubham, Utkarsha, Reena, please do that. The YouTube link has been put on the chat so that those who are having difficulty in connection can use the YouTube link and share with your friends if they wish to. Today, there are many things that we would like to achieve in the time that we have. We would like to look at, first we will review briefly the preparation that you have for your projects. We are going to have presentation on December 1st, 2nd, and 3rd. So any doubt, we will discuss that. Then we will talk about learning from nature. I'm sure some of you know more than I do about biology. So I would invite you to talk about subject you know better. Or if you know of examples in your lab where you have used natural analog for solving a problem, that would be very nice. I will show you a very interesting example from MIT, a PhD student, how she used a very simple phenomena of nature, xylem and phloem. If you know any student of, you must have studied in class 10th botany science that in plants, in trees, in any plant, there is an upward movement of water or nutrient and downward movement of nutrient. So photosynthesis takes place, that nutrition goes down into different parts, and from the root, nutrients go up. So xylem and phloem, two parts of the particular tree trunk, how they have properties, and I will ask you whether you make any sense of this property of the tree for solving a real problem of our life. And that's the question that a PhD student asked in MIT and found a beautiful solution with a very simple technology. So profound solutions don't have to be complex, but we can learn a lot from nature. I want to show you some examples of that. We will also talk about Shodhyatras as to how we do that, what have we learned from there. And in case some of you wish to join, we will be very happy to have you with us. The next class is going to be on incentive. So I will talk about a few models of leadership and also talk about incentives so that for the next class, you can bring some examples. We will do an exercise in the next class on different kinds of incentives: material, individual, material, collective, non-material, individual, and non-material, collective. 4 kinds of incentives, and which one influence our behavior in what way. And therefore, when you become leaders of your lab, of your institution, of your domain, of your profession, how would you use this portfolio of incentives to motivate younger people to get the best out of them? So after 20 years, 25 years, when you are leader of the profession in the world, you might remember this class or next class. So I'm going to invest for that time. At this moment, it's too near to our goal. So obviously at this moment, you're all focused on finishing a PhD. But while doing so, we can build our perspective of how incentives work in our life or do not work in our life. We will also, then after that, last class is on policy institutions. What kind of policy changes, institutional changes we need to bring about so that our ecosystem works better. So I'll share with you some findings of my study during the COVID period. I talked to many biotech entrepreneurs to understand what problem they were facing. Those who were developing diagnostics, those who were developing plastic, those who were developing reagents, and what kind of interface between what they were doing and what our policies were, and how both were sometimes contradicting, sometimes converging. Something that I have shared with Deputy Secretary, Principal Secretary to Principal Advisor to Prime Minister and other people, but I would like to share with you also so that you know that there is a context of policy which scientists often overlook. And then we complain that policies are not right. We have to engage with the policy making process and policy modulation process so that we can make an impact. So this is the plan for the next 2 sessions, motive, incentives, and then policies, but we'll come back today. So any comment, any question about your projects, any clarification that you need, we can spend 5 minutes on that. Chaitanya, please switch on video. Deepak, Anil, Bhushan, Reena, Aishwarya, please. Mohammed Tausif, Devitulya, please. अनुपमा, आपसे मैं काफी बार रिक्वेस्ट कर रहा हूँ, आपका कनेक्शन तो ठीक है, प्लीज स्विच ऑन. श्रुति, यस, दैट्स वेरी नाइस. नहीं, अंधेरे में चली गई आप, पहले उजाले में थी. हाँ, आप ठीक है ना? ठीक है. मोहम्मद तौसीफ, ये 91831 आपका नाम क्या है? आप नाम क्यों डाल देती हो यहाँ पर बच्चे? 91831 आप आपका नाम क्या है? आप नाम रीनेम कर दो ना इसको. मैं बोलो, आपका नाम बोलो, मैं डाल देता हूँ आपके इसमें. क्या नाम है आपका 98131 का? अनम्यूट करो. आई पुट योर नेम हियर. मैं डाल रहा हूँ. आप नाम बताओ अपना. 9183. हाँ, बोलो, नाम बोलो.
स्नेहा सर.
हाँ,
स्नेहा.
शिखा.
स्नेहा.
लो, मैंने आपको नाम डाल दिया. अब आपका नाम पे स्नेहा आ रहा है, देखिए. तो आपने नंबर डाल रखा था, पता नहीं चलता ना कैसे बुलाएंगे आपको हम. 91831
क्या आ गया है सर?
ये तो जेलियों के नंबर होते हैं, प्रिजन में होते हैं ना, जो कैदी नंबर 10, कैदी नंबर 50. तो
नहीं सर, वो मिस होके आ गया है.
कोई बात. तो इसलिए चलिए, तो बताइए, कोई प्रोजेक्ट के बारे में कोई क्लैरिफिकेशन चाहिए तो बताइए. फाइनल प्रोजेक्ट जो आपको प्रेजेंट करेंगे 1, 2, 3 में, उसके बारे में कहीं किसी को कोई डाउट है, कोई क्लैरिफिकेशन है, तो अगर नहीं है तो बहुत अच्छी बात.
गुड इवनिंग सर. आई हैव हाँ जी,
बोलो.
आई हैव अ क्वेश्चन. सर, वो मैंने आपसे लास्ट टाइम डिस्कस किया था, हमने मेडिटेशन इंटरवेंशन जो पीएचडी स्कॉलर्स को देना है उसके बारे में. तो सर मैं पूछना चाह रही थी कि हम ऑनलाइन प्लस ऑफलाइन दोनों मोड्स उसमें रख रहे हैं ताकि हमारे पार्टिसिपेंट्स जो है मैक्सिमम हो सके. तो उसको हम ये वाले ग्रुप के साथ, सारे जो CSIR इंस्टीट्यूट्स का जो ग्रुप है यहाँ पर, उसके साथ शेयर कर सकते हैं वो लिंक, ताकि हमें यहाँ से भी पार्टिसिपेशन मिले.
करो, लेकिन मेरी बात सुनो. प्रोजेक्ट का ना कुछ उसमें साइंस तो होगी कि नहीं होगी? कुछ मेजर करोगी, कुछ इवेल्युएट करोगी?
हाँ जी सर.
हाँ, मतलब कुछ मेजरमेंट होगा ना थोड़ा सा.
हाँ जी सर. प्री और पोस्ट असेसमेंट.
मेक ए साइंटिफिक स्टेटमेंट कि भाई ये था स्टेट ऑफ व्हाटएवर स्ट्रेस वाज बिफोर एंड आफ्टर.
यस सर.
उसका एक टूल बना लेना
जिससे
आप मेजर कर सको, ठीक है ना?
यस सर.
और do share. No, I have no problem with that. Anybody wants to share their project link or project goal, or you want some feedback or participation from other people, please do put on the chat.
ठीक है सर. और सर, इसके लिए हमें एथिकल कंसेंट की जरूरत पड़ेगी CSIR?
एथिकल कंसेंट की आप लिख देना कि you assume that those who are participating have given you consent for the participation and they are responsible for what they're doing. बात खत्म हो गई.
ओके सर.
हाँ, तो कई बार क्या होता है ना कि इसके अंदर कंसेंट होना चाहिए जब ह्यूमन सब्जेक्ट होते हैं.
कंसेंट तो हम डालेंगे सर गूगल
फॉर्म.
फॉर्म.
आप एक स्टेटमेंट डाल देना उसके पहली स्लाइड में ही.
हाँ जी.
And you can say that anybody who does not agree with this can exit.
हाँ जी, right sir.
So then people can go out if they don't want to agree with what you're saying.
Right sir.
Generally, it's a good protocol that you define the ethical obligations and tell people that at this moment I give you 30 seconds to decide whether you want to continue or not.
सर, हमारे CSIU इंस्टीट्यूट से तो जरूरत नहीं है एथिकल कंसेंट.
नहीं, आप डालो ना, सब जगह डालो. जो प्रेजेंट कर रहे हो आप उनको भी दिखा दो स्लाइड. कोई बुराई नहीं है. देखो,
हाँ जी.
ऑफलाइन हो तो भी आप बताना चाहिए, क्योंकि people should have a right to make informed choices. इसको बोलते हैं prior informed consent. PIC.
हाँ जी सर.
जरूरी.
ठीक है सर.
Anybody else? एक सवाल आया कि when will we present? December 1, December 2, December 3. These 3 days we will have presentation, and I would suggest that we make brief presentations so that nobody goes out of time. Sometimes some people take a lot of time and other people don't get much time. So keep time budget. I will request your help. Yes, Ashwati?
Sir, actually, last class I have said about that the project topic like eco-friendly R&D labs, and also
Yes.
is it required that we have to completely implement every task we are doing, or we can give a
Well, may not
calculation?
be possible. May not be possible.
But we can
Do
give that
as
how
much
much
as
is
you
water
can.
we are
Do
saving,
as
what are the
much as you can.
calculation?
But
Yeah.
give a model which, if somebody wants to implement, they can.
Yeah, models तो हम बना ही रहे हैं.
Right.
Okay, sir. Thank you, sir.
Yes. Anybody else?
Sir, good evening, sir.
Yeah. Good evening.
Sir, before this lecture, I asked you the same question. When do we have to present the final project? You told us
Final
that
project is last week of December or first week of January. Ashwini is there. Ashwini, have you joined today? Or anybody from
Yes, sir, I have joined.
ACSIR is there? हाँ?
I have joined, sir.
हाँ,
Yeah,
तो
the
बताइए
dates which
इनको
you
लास्ट
sent,
डेट क्या है? जनवरी फर्स्ट वीक रखेंगे या कब रखेंगे? ये
sir,
टर्म कब खत्म हो रहा है?
sir, around mid of January session start होगा.
अच्छा, तो फिर
तो sir,
15 जनवरी रख दें या 10 जनवरी?
हाँ जी.
ठीक है, तो
सर
15
15
जनवरी
जनवरी
रखते हैं.
बात हुई थी आपने
हाँ,
पहले बताया.
ठीक बात आपने कहा था. तो
जी.
15 जनवरी तक आप भेज दें तो is it enough time?
yes, sir. And
Yes, sir.
on third or 4th December,
नहीं,
we
third
have
नहीं,
to,
first, second, third.
yeah, 1st, 2nd, 3rd December, we have to present only the outline.
Yes, right.
But sir, there is like a request from my side. I'm actually from CSR NCL.
Uh-huh.
We are a group of 5 students. We had actually already registered for a conference in Uttarakhand.
Okay.
Before this circular came up, before this
नहीं,
lecture came up.
कोई बात नहीं. तो आप ऐसा करो, आपके पांचों के पांचों गायब होंगे या एक जना रहेगा कोई?
No, we all are going. So we are
Okay.
going from 28 to 8th of December.
नहीं तो then you can't attend from Uttarakhand.
For 28 to 30, we will be in train. Then we will be attending conference. So
सही
I
बात
don't
है.
know.
मैं कह रहा हूँ शाम को हमारा सेशन तो शाम को होता है, तो
नहीं
शाम
कर
को
सकते हैं, अगर possible रहा तो कर सकते हैं. It's not a
कर लेना,
problem.
नहीं तो भेज देना, नहीं तो मेल से भेज देना. ठीक है ना?
Okay, sir. Okay.
हाँ, कोई बात नहीं. और आपका कोई और दोस्त है तो उसको बोल देना, आपकी जगह पर थोड़ा सा ब्रीफली बता देगा सबको. ठीक है ना?
We will present, sir. Four group
ठीक.
members are there.
ठीक है. ठीक.
Okay. Thank you.
Anybody else? Any other question? And I'm hoping that you will all give us consent to share your projects widely. We will try to put them on the portal so that anybody in the world would know what you are thinking about, how you are solving these societal problems. So please, if anybody has any reservation in the sense that either you are focusing on some IP related issues or you think your ideas are not mature enough to be shared at this moment, please put a remark that this is not for public dissemination. If you do not put any restriction, we assume, and I'm taking your consent now, I am assuming that we can share your project with anybody and everybody. Right? This is recorded now. So if anybody has any objection, mention clearly on the top of a project. On the top of a project. This is for restricted use and evaluation only. It is not meant for wider use. All right. Okay, so that means there is no other issue. We will begin now further. So there are two issues that we are going to discuss. First, we will talk about the Shodhyatra, learning from nature and Shodhyatras, and then we will talk about the biomimicry. And those of you who have dealt with biomimicry, I will request, do share your thoughts about biomimicry, because it will be very nice if you did that. One second. Yeah. Okay. What's happening? Let me do it again. All right, so let me first explain why do great societies sometimes decline or become introvert? And this is a question that we should all ask, because we have a notion that we were great at one time and we have declined, or we are not going fast enough. And my suggestion is that when we stop talking about ideas openly, we stop criticizing each other, critiquing each other, and constructively criticize also sometimes. When we fear that our views might not be acceptable and therefore we don't express them, when freedom of expression is subdued, when ideas are confused with individual, that means if I'm critiquing your idea, that means I'm critiquing you, which is not true. I like you, I respect you, you're my very dear friend. That does not mean that I and you should agree all the time. So disagreement is not a sign of disrespect, but very often this confusion arises in society. So when society stops distinguishing between ideas and individuals, problems happen and society will decline. So we need to understand that our society, wherever excellence has existed, how did they manage to maintain that excellence? How did they have a culture of sharing? How did they learn from each other? What was this university of open learning that many of us may not have realized in our life, but which existed very much, exists today also? There is this huge to and fro transaction that take place in the communities about problem that people face. And if somebody's child is not well, they talk to an elderly lady or some lady in the neighborhood and ask them as to what happens. And then this is how society learns and solves their problem. But when they become secretive, when they become restrictive, when they don't share their ideas openly, problem arises. And this is one of the contention that I'm making there, that one of the things that we have learned during our walks in different parts of the country is that there is a lot of openness. Barring a few cases, most people have been very open about this. So we have been looking for hotspots of innovations, new kinds of solutions, traditional knowledge, knowledge of biodiversity, knowledge of food, recipes. So what do we do when we start walking for Shodhyatra? So in summer, as I told you earlier, we go to hot places. Winter, we go to cold places. And we learn from 4 teachers: teacher within, teacher among peers, teacher in nature, and teacher among common people. These are the 4 teachers we learn from. Not everybody learns the same thing. And I also have a course at IMA, Shodhyatra, very difficult course to enter because there are 500 students and we only take 30. So people have to, there's a bidding, and this is one of the most difficult courses in India to enter. You can imagine. So that's another way in which we learn. I take students to Himalaya and we track, we stop somewhere, we learn, if there's a spring, we sit around it and didn't talk about different challenges in our life. So it's a walking course, it's a walking journey, and I would suggest that sometime you should experiment with it. If either alone or with a group of few, walk slowly. For learning fast, we should walk slowly. And that's very important because we want to observe a lot of things that we have observed all the way. So when we map creativity and we tap innovation, we also tap inertia. One reason why we sometimes don't get the energy or courage to take action is because you're not getting enough motivation. So I'll give you an example. How knowledge flows to you when you are sharing. So there's a professor in Scotland, Bob Osco. He went to Mongolia And he observed that herders in Mongolia, as some of you know, Mongolia has a large steppe terrain where animals, sheep, cattle, goat, they are taken for herders by the pastoralist. So he observed something interesting. They had a problem of premature abortion, or sometimes the young ones will not survive long. Infant mortality, so to say, calves did not survive. So they developed a solution. They took onion leaves, wheat bran, condensed milk, and made a lick out of it. And this was given to animals to lick. He knew that I'm interested in what communities find solutions to. So he wrote to me. He published this in Honeybee. Then I went to Canada and was talking to indigenous people, Mahowak people on the border of Canada and US. And these are indigenous people. Some of them had started keeping animals, and they had the same problem that Bob Oskov had observed in Mongolia. So from Mongolia, it came to Scotland. From Scotland, it came to India. From India, it goes to Mahowak community in Canada. And now my question is, some of you might know, what is that element which is present abundantly in onion leaves, which might be preventing this problem of abortion and or premature death of the calves? What is that? Anybody has any idea which element it is?
Sulfur.
Sulfur is there in onion, but I'm talking about onion leaves. Sulfur, you are right in the onion. In the sulfur, sulfur is very important for, of course, skin diseases and other things. Yes, allergies and so on. But any other idea? Any other element that you know?
Quercetin.
Huh?
Quercetin.
But actually selenium.
Oh.
So you know selenium is about 40 microgram to 400 microgram. That's the range within which if it is too much, it causes toxicity. If it is too little, the symptoms become very evident. So selenium is very important, of course, in veggie, and it's found in nuts. Those who are non-vegetarian can get it in fish and eggs and so on. Grains, well, leafy vegetables have some, but onion leaves have been, garlic and onion leaves have been used for a long time to have this. So Shodhyatras make these connections possible. We can connect things from one place to another. Leucas aspera is a plant that some of you might know. It grows on roadside in large parts of the country, at least in 5 states: Bihar, Odisha, Jharkhand, even in Gujarat it is found, West Bengal. And we were very intrigued that there were some uses which are common, which people had discovered. So if you are tired and you are exhausted, then many times the workers would make curry or sabzi of it and eat it. And it was supposed to be very relaxing and give them energy. So there are a lot of such connections across the country that we have observed. We were walking in Andaman, and we found one lady. We went there for fetching some water. We were feeling thirsty. So she was taking out the leaves of morning flower. What do you call that? That grass which flowers a lot, purple colored, yellow. They're different color of flowers. Anybody knows the name of that plant? Morning flower. What is it called? Scientific name. This is a grass, and so what they were doing, they were collecting it, and she was taking the leaves of this grass. So we asked, why are you collecting it? And she said, this is very good for diabetes. My husband has a problem, so I give it to him in the morning, and he finds it very useful. That was very interesting. We had never come across this example before. But when we saw that, we said, that's true. So we can perhaps do research on it. And then we found that there were some studies done, not too many. So connections, let us see how the connections, I talked to you about this. This one is a very interesting example. Did I tell you about the story of drop of water? 2,000-year-old story. Did I mention in previous classes? But sometimes I forget. I'm teaching several courses, so I mix up sometimes. Have I taught this, Pradita? Have I told you the story? No?
No, sir.
So I'll tell you the story, because this story will come up many times during our class today. Because I'll show you some examples from Mizoram, from Meghalaya, where this drop of water has been very important driver of innovations. Just one drop of water. So 2,000 years ago, a teacher asked a student to bring a glass of water. So he went and brought a glass of water, and he put the water in it. He took the water, gave the glass back. The student went back to the kitchen, kept the glass there. So teacher asked him, what did you do? Sir, you asked me for a glass of water. I brought the glass of water. You took the water. I kept the glass, empty glass back in the kitchen. No. Tell me, what did you do? He repeated that. You know what he missed? Anybody can guess? After some time, 7, 8 iterations, he said, now I know what I did. What did he know? What did he discover? Suddenly remember. Just guess, wild guess. Just guess. What would he have done? Anybody?
Served him.
Sorry, yes. Huh? Sorry?
Sir, student just threw the left out water.
Yes, you are right. किसने बोला है?
मतीन नूर.
क्या नाम?
मतीन नूर, sir.
बहुत अच्छी बात बताई भाई तुमने. 2000 years ago उस टीचर ने पढ़ाया था, तुमको अभी तक याद है? You remember that lesson. So what did he do? There were a few drops in that. He threw them on the ground, and this drop that he threw on the ground, he remembered it now after he repeated asking by the teacher. Sir, you asked me for a glass of water. I brought the glass of water. When I was going back, I threw just a few drops. Just a few drops. The moment he said just a few drops, he got his Zen. He got Gyan, Nirvana. So the question now is, why would Buddha, 2,000 years ago, teach a parable about a drop of water? For the next 1990 years, there was not going to be shortage of water. Our civilization it evolved around the river banks. So we had always with sufficient water. There were people in desert, but they also conserved water in the wells or in the bodies and all of that. So how did he anticipate 2,000 years ago that in 2021, there will be so much of shortage of water that people will have to struggle for even a drop of water? So one of the things that we have found in our Shodhyatras, that many times when they build institutions of conserving natural resources, they have great foresight. Great foresight. You remember I told you last time about the bridge that Meghalaya people made of tree roots. And it takes 50 years to make, it lasts for 200 years, 300 years. Which is the project that you imagine which lasts for 200 years or 300 years? Or you remember any project which started, let's say, 50 years ago and has just been finished? Rarely would you remember something of that kind. So we realize that foresight is a very important question. I'll give you another example. Japan, 1868-69, when Meiji Restoration took place, the new king of Japan, they sent people to different parts of the world to learn about education. So they said they went to Sierra Leone in Africa, which was called as Manchester of the East of Africa. They sent to Europe, they sent to India, they sent to various parts, China. And that time it was shipping only, the means of transport. So the people came about a year and a half. They put together a report. I have a summary of that report in my library. The title of the report was 200-Year Perspective Plan of Education. 200 year. Have you ever seen any Indian plan of 200 years? Japan made in 1868 a 200-year perspective plan for education. What was the result of that long-term planning? By the turn of century, Japan became the first Asian country to be 100% literate. That's the power of long-term dreams. Long-term dreams prepare us to get them realized much faster than otherwise they would be possible. It pays to have long-term dreams. Dreams after 50 years, 70 years, 100 years, 200 years. And you might say, but we will not be alive. That doesn't matter. Society will be around. We can plan for that long time. Societies which are developed have long-term vision. Societies which are developing or underdeveloped, they look for next year or next after year. So please remember, this is a very important part. Very important.
जिसमें हमें सोसाइटी के बेनिफिट के लिए जो वो मैं सर्वे वाला करूंगी.
Mute yourself, mute yourself. So let's go further. So I'll come now from 2000 years to 20 years. And 20 years ago, I was walking, which was one of our early Shodhyatras, second or third Shodhyatra. And we met a shepherd. He was carrying about 200 sheep. So we waved, "Bhai, rukna zara, baat karni hai. Please stop." So he stopped. So I had a paper in my hand, which had a program of Shodhyatra. So I had rolled it like this. And I said, "Tell me," and I thought I'm a professor from IIM, I'm asking a very intelligent question, and you will realize now what a fool I was. So I said, let's say if one of the sheep from your herd gets mixed with another herd, another person's herd, how will you find out? He said, "Give me this piece of paper." So I gave the piece of paper to him, which had a program of Shodhyatra, where will we go for lunch, where will we stay in the night. He said, "To me, all the letters look alike." He said, "To me, all the letters look alike," and laughed and went away. Oh my God, that was a slap on my face. I was illiterate in his language. To me, all the sheep looked similar. To him, all the words looked similar. All the letters seemed similar. He was illiterate in my language. I was illiterate in his language, and yet I was making fun of him. I will never forget this lesson. I always tell this to my students to just show how naive we can become. We claim to be very wise, but sometimes we make such foolish remarks as I did at that day. I will never forgive myself for that. But nevertheless, it taught me a very important lesson, that don't underestimate power of people to make sense of things around them. So it might appear that 200 sheep, how can I remember? I don't remember the name of the students in my class many times, even if they're 50, 60, or 100. And to him, for him to recognize all the 200 sheep by their characteristics or sound or color or whatever was, of course, a challenge, but he knew that. So it is very important that we have encountered sometime to learn about the wisdom that our society has. And we have had many examples. I'll show you one more example. So we were once, there was a friend of ours, Jayanti Bhai Patel from ISRO, Indian Space Research Organization. And there was a development communication unit. So we had gone for making a small film. So Karim Bhai is a healer in North Gujarat, Viramgaon. He's a potter, but he also gives medicines. There's a forest nearby. There's a sloth bear sanctuary. So he goes and collects the plants from there and gives medicine to people freely, or somebody wants to pay anything, then he takes, but he never asks for money. So he was sitting on a stone, and I was sitting on another stone. The cameraman was trying to adjust the camera. And then the cameraman said, "Maybe we should keep Karim bhai, please keep a twig in your hand when you explain how you use plants. So he plugged a twig of a plant from the roadside and gave it to him. Karim Bhai got upset. I said, what happened? Why are you upset? He said, did we need this twig? I said, well, it would look nice in your hand. He said, then you should have told me. I would have sat near the plant. Why, like a fool, I said, but there's so many of these plants. What if I took one twig? He said, what did you say, so many? In nature, there is never too many. Every blade of grass has a unique niche to which it fits. Earlier, I used to pluck grass when I was sitting in the lawn, and I will crush it in my hand. When I'm standing near a shrub, I will take out some leaves and I'll crush them in my hand. Just like that, just for no reason. And now the moment my hand go there to pluck some leaves, Karim Bhai comes in front and says, do you need them? And I immediately become conscious and I don't do that anymore. But I have done it many years before that event. So this whole issue of every species, every plant, every individual of nature has a place in itself is very critical, very critical. And we need to remember that. We often assume that how would diversity be embedded in this, but it is important. Another interesting dialogue, a simple dialogue about how we look at the role of wildlife. So we were walking, this was our first walk, I think in 97, 98. We were very close to the Gir Lion Sanctuary. So one or two villages before these sanctuaries, about 7-8 kilometers before, and we met a very wise person, Ilyas Bhai. So he was known for the knowledge of wildlife. People had told us, "Jahan jao to Ilyas Bhai zarur milla." So we stopped by and asked again a question: when does lion come here? He said, sir, lion stays here. It is you people who come and go. Change the perspective. Immediately change the perspective. बोले शेर तो यहीं रहता है, आप लोग आते जाते हैं. Just change the way. I mean, to whom this land belonged? Of course, land. It was habitat of lion. So this whole stretch belonged to him. We have put those boundaries. Here is a sanctuary boundary. Here is a farm. But at one time, they were moving around everywhere. So it's just a way of looking at nature. So we talked about her, how in Champaran we had met her. Beautiful grain bin. And this example, I don't know if I gave you, but it's a very interesting example. In many houses, they put pots of clay pots to bring pigeons, and they collect the excreta of the dropping of the pigeon. It's a very good manure. The first fertilizer that was ever used in agriculture, history of agriculture, was guano from Amazon forest. It was collected and shipped to England. That was the first time when organic fertilizer or any fertilizer from one place to another was transported. So these people have been doing it for millennia. They invite the birds so that they collect the dropping and they use this dropping for their small farms that they have. You know that these droppings are very rich in phosphorus and other nutrients. What do we do? So this is a place in the institute that I have been teaching. And they don't let birds come. They put spikes, then spike didn't work. They put a sheet, keeping birds away. So look at the contrasting culture. In Jharkhand, people are trying to bring the bird to their home. In my institute, they're trying to keep the bird away because they think the bird is distant. I didn't allow this to be done when I was in office. I've now retired, so I've vacated my office, but I kept it for 30, 40 years. And there were spikes on the top. Vishal. So it's very interesting to see the contrast, what role nature plays in our life. How are we trying to keep away? Many of you may know that the first bread you cook, do you eat it? क्या करते हैं पहले रोटी को? What do you do? Some of you at least must be doing something with that. आपके घर में पहली रोटी बनती है, क्या करते हो? You give it to cow, you give it to dogs, you give it to birds. In our home, we give it to the birds. So the point is that we want all to remember that nature is part of our being, that a share of nature must be taken out every day, every meal. This is a culture. And this culture is getting weakened. But some people do that. I see in the morning walk, when I go for morning walk every day, I find some people carry a bag of flour and they give it to the ants. Some give it to the pigeon. Some carry biscuits for the dogs, stray dogs. And this is so nice to see how people think that in their life there is a place for other beings, the other sentient beings, non-human sentient beings. And this is very important part of culture. If we can sustain this, we will discover many interesting ideas from that nature. Because when we go close to nature, we will observe. I also collect Aparajita flowers. Do you know Aparajita flowers? Every day morning, I'm a flower gatherer. So I collect these. They're also white, but they're also purple. So let me show you. So this is, can you see that? So this is Aparajita flower. There are white also. And I collect them from the bushes every day morning. Bring them, dry them. Here is it. So I have got these flowers in my office also. They are dried. I keep them here. I make tea of it. Drink it. Every day I do that. This is my daily routine. Now, some people observe, what is this man doing? He's collecting some flowers from the thorny bushes and this and that. But I do that because I find this is extremely refreshing. Those of you who are not aware of it should use it. And if you have a problem of hair falling, my God, this is so effective. Try to take tea for a week and you will see the difference. All right? Yes. कल्पना आपको पता है कि नहीं पता है, मुझे मालूम नहीं है, लेकिन अगर आपको नहीं पता हो ना, तो आप इसके चाय जरूर पीना. I will make it now. And it is a blue color tea. And it's very refreshing, very refreshing. We have made, my Kuli Chetan has made many variations of it with different spices. You can try whatever you want. But the point I'm driving home is that it is possible. Did you see this flower? I mean, let me share it again. I don't know whether you saw. This is the flower I'm talking about. Clitoria tornati. And this, I'm just mentioning that these are small things. Earlier, I forgot the name of the plant, Morning Glory. That was a plant for which the leaves of that, small leaves of that were used for diabetes. So man, it doesn't cost you anything. And there's no shame in collecting from the roadside, from the shrubs. What is the shame? I don't care if anybody bothers about it. But this is where we keep the food gathering and hunting culture alive. At one time, we were all doing that, isn't it? Why not? Why shouldn't I continue my food gathering instinct? It gives me a feeling that I'm still evolving, you know. Some of us think that as if the days of gathering are gone. No, it is not gone. It is still there. So we need to bring nature into our life so that we can observe it closely. And I will now show you something about a very interesting thesis that I mentioned to you. Can you tell me what phloem and xylem, what can we make from this property of trees? Anybody can tell me? Huh? Anybody? I'll show you, but I want to ask you first. And high quality science, very high quality science. I will show you in a high quality science. You'll be amazed by the simplicity of the idea and complexity of the science, both at the same time. The question is, I am repeating the question. Trees or plants have a property, they have xylem and they have phloem. One takes moisture above, one brings moisture down. What can we do with this property of wood? Can you make a daily life product? Anybody, please. Exactly, Surjit. Surjit, जरा अपना वीडियो ऑन करो. देवेंद्र बोलो, देवेंद्र बोलो.
Sir, we can make water filter.
सही बात है. देवेंद्र तुम भी ऑन करो अपना वीडियो. सुरजीत तुम भी ऑन करो. जरा मुझे बताओ क्या करोगे, कौन सा ट्री यूज करोगे, कैसे बनाओगे, बिकॉज देन यू आर ऑन द एज. तो हम लोग बोलते हैं MIT में बड़ा अच्छा काम होता है, तो क्यों हमारे यहाँ नहीं होता? काम होता है भाई, लेकिन हम छोड़ देते हैं ना ऐसे सवालों को. बस वी थिंक इट इज टू ऑब्वियस. इट इज नॉट सो ऑब्वियस. अभी मैं दिखाऊंगा आपको 1 मिनट के अंदर. देवेंद्र बताओ जरा क्या करेंगे, कौन सी वुड यूज करोगे?
Sir, we can use the process of reverse osmosis.
नहीं, रिवर्स ऑस्मोसिस क्यों करना है यार, सिर्फ फिल्टर करना है ना.
Yes, sir.
तो कैसे
We
करोगे
can
filter?
just we can pass through the plant. The water we can pass through the plant.
A small piece of wood.
Sir,
Which
we
wood
can
will
make
you
membrane
use?
filter.
देखो ना, फ्लोएम में एक साइड में कैपिलरीज हैं, जाइलम में दूसरी साइड में है, करेक्ट है ना? तो कैपिलरीज बनी हुई है उसके अंदर.
Yes.
तो हमें उसी डायरेक्शन में रखना है जिस डायरेक्शन में वाटर को फ्लो करना है.
Yeah.
ठीक है कि नहीं? अब देखो क्या करता हूं मैं, दिखाता हूं आपको, ये थीसिस दिखाता हूं. एंड जस्ट लुक एट दिस वर्क. सो दिस इज द वर्क by an Indian student. Her name I'll tell you just now. In Nature Communication published हुआ है भाई. ये छोटे मोटे जर्नल में नहीं छपा है, नेचर कम्युनिकेशन में छपा है. एंड रोहित कार्निक was the professor and the student was कृतिका रामचंद्र. ठीक है, she was the PhD student. Co-author says paper में कृतिका and Luda, and the paper was published in, and look at this what they did. This is a pine tree. ठीक है, ये पाइन ट्री की छोटी सी ब्रांच की वुड ले ली इन्होंने, ऊपर से बार को हटा दिया. ये ट्यूब ली पानी की. मैंने देखा ये एक्सपेरिमेंट व्हेन आई हैड गॉन टू मीट संजय शर्मा, माय डियर फ्रेंड इन मैकेनिकल इंजीनियरिंग. इट वाज पार्ट ऑफ हिज लैब. वहां उसने बोला अरे जाके देखो जरा क्या कर रहे हैं लोग. एट दैट टाइम शी वाज जस्ट बिगिनिंग हर वर्क मैनी इयर्स अगो. तो ये आप ट्यूब के अंदर वो लकड़ी लगाई हुई थी इसने. उस समय डिस्चार्ज बहुत थोड़ा होता था. So now you see this is the filter put in the tap and the water is coming clean. Now what did she do? She has gone into the anatomy, into the structure, the mechanism, flow rate. Oh my goodness, the whole science of it. So xylem, which draws water up to the tree trunk. Now mind you, when water goes against gravity, will those capillaries be stronger, isn't it? Then the one when it comes down. So उसने xylem use किया, phloem use नहीं किया. And these conduits are interconnected with thin membrane that acts as natural sieves, filtering out bubbles from water and sap. तो जो pine needle है, pine wood है, उसकी natural filtering ability को use करके they made a low tech design effectively filtering bacteria. Can you imagine? Even a bacteria cannot pass through. ये है putting high quality science using simple solution with high complex science. Nature, सिर्फ nature से सीखा भाई. तो आपको लग रहा होगा मैं क्यों आपको nature से सीखने के लिए बोल रहा हूँ यार? Because we can make breakthrough. Nature से बड़ा teacher तो कोई है नहीं दुनिया में ना. There are large number of processes in nature we are yet to understand. So they fabricated a xylem filter which can filter out E. coli, rotavirus in the lab test. Can you imagine? And simple techniques to extend the water filter's life. क्या करते हैं उसको? 2 साल तक उसकी लाइफ रहती है, बताइए फिल्टर की. 2 साल, 2 years. And this was published in Nature Communications. Now they are making it available larger scale where there is a water is contaminated. Raw material is widely available. Fabrication process simple. One could imagine involving communities in procuring, fabricating, and distributing xylem. Democratize हो गया science. And now the mountain people will make water filter and sell it to everybody in the place. Delhi में आप वहां से खरीद के लाएंगे उत्तराखंड से. तो उनके पास पैसा जाएगा ना आपकी जेब से, तो इकोनॉमिक डेवलपमेंट भी हो गया. Good science generates good social relations. Please remember, good science generates good social relations. And it is affordable. This is how she is the student. इसका देख लेना वीडियो दिखता है तो. Just about 3 minutes. Are you able to hear the sound? No, wait a minute. I'll put it again. No, just a minute. Let me do it again. Share the sound. Okay. Now you can hear?
Yes, sir.
इस्लाम है दिल्ली का जहांगीरपुर।
यहाँ पानी की बहुत परेशानी होती है, पीने वाला पानी बहुत गंदा आता है, जैसे कि ये पानी नाले जैसे एकदम बदबू आता है इसमें, और पीने का पानी जब घर में नहीं रहेगा तो गंदे पानी पिएंगे लोग। हाँ, बीमारी हो जाती है, लैट्रिन भी होने लगे, पेट में दर्द भी होने लगता है, और जो है कि हर किता की बीमारी होती है पानी से।
Oh, sorry. What did I do? What did I do? Wait a minute. No. What did I do? एक मिनट, दोबारा, let me do that again. What did I do?
और यहाँ पानी की बहुत परेशानी होती है, पीने वाला पानी बहुत गंदा आता है, जैसे कि ये पानी नाले जैसे एकदम बदबू आता है इसमें, और पीने का पानी जब घर में नहीं रहेगा तो गंदे पानी पिएंगे लोग। हाँ, बीमारी हो जाती है, लैट्रिन भी होने लगे, पेट में दर्द भी होने लगता है, और जो है कि हर किता की बीमारी होती है पानी से।
पानी से जुड़े काफ़ी इश्यूज देखने को मिले। पानी गंदा आता है, लोग कैंपर का पानी यूज़ करते हैं। हम लोग 2 साल से MIT की टीम के साथ इस वाटर फिल्टर पे काम कर रहे हैं। ये लोग हमारे फील्ड में आते हैं उत्तराखंड में, तो हम लोगों ने अप्रोच किया कि क्यों ना आप एक बार यहाँ पे भी टेस्ट करें वाटर। यहाँ पे पानी की काफ़ी समस्या है और पानी काफ़ी दूषित भी है, पीने के लायक नहीं है।
इसमें ऐसे बहुत छोटे छोटे छेद हैं। डायरियल डिजीजेस which are caused by the microbial contamination of water, they cause about 500,000 deaths worldwide, and the incidence of these diseases is particularly high amongst children who are below the age of 5 and in resource limited settings. The main source of water is through like municipal tap water supply, and what we heard from people was that the quality of this water that's supplied is not very good. So A, because of the taste, and B, because also of the odor. In order to get drinking water, what people here currently do is that they buy these RO based water cans that are delivered for like 20 rupees or something per can. So I started working on this project in 2014 when I joined MIT. I got a chance to speak to Professor Rohit Karnik, who is a faculty member in the mechanical engineering department at MIT. And that's when he told me about this idea where you could use wood as a water filter. मैं एक लकड़ी से filter बना रही हूँ. So there were a couple of things that really interested me. So one was the simplicity of the idea that you could use something like naturally occurring wood for filtering water. The second was I also really liked the application aspect of it. So as a part of the Tata Center, we are encouraged to focus on the implementation aspect of things also. Our lab experiments involve using locally available wood, but then can we actually manufacture these filters locally in India? So the idea of using wood was something that people really liked. We asked people if this is something that becomes available at 15 to 20 rupees, would you mind replacing it more frequently, but like paying less every single time? And a lot of people said yes. In the long term, if this is a product that performs well, I would definitely like it being used by a lot of people here. And if that helps reduce the burden of disease, then I would be really, really happy.
So as you can see, what do you think about this idea?
Hello, sir.
Yes, Rajani.
Can I say something?
Go ahead.
Sir, in our village, mother used to filter water using this pot made of मिट्टी का जो ये होता है पॉट होता है बड़ा। हाँ, मटका। फिर उसमें सैंड और ये वुडन का जला हुआ ये काला काला वो डाल के पानी प्यूरिफाई करते हैं। फिर उसमें से ड्रॉप वाइस से पानी आता है। फिर वो जो पानी आता है उसको आने के लिए मम्मी ने ये वुडन का छोटा ये स्टिक यूज करते थे, उससे ऐसे फिल्टर होकर ड्रॉप वाइस आता था। सर कॉन्सेप्ट सेम ही है सर।
मतलब थोड़ा फर्क है क्योंकि वो पानी ड्रिप से आता था, उसमें ट्विग होगा, मतलब वो होगा गांठ, कोई कपड़े का कुछ गांठ होगा या लकड़ी का होगा, मुझे नहीं मालूम। लकड़ी का था तो वही बात है। सवाल ये है कि आपने देखा और आपने उस बात को वहां पर छोड़ दिया।
Yes, but I don't know this.
नहीं, लेकिन आपका क्या बैकग्राउंड है रजनी?
सर केमिस्ट्री।
तो यार ये बताओ ना, उसने तो अच्छी फिजिक्स भी यूज की, केमिस्ट्री भी यूज की, ठीक है ना?
Yes.
और क्योंकि बायोलॉजी तो है ही है इसके अंदर। मेरा मतलब ये है कि इफ वी कैन लुक एट नेचर, आपकी जो सोसाइटी के जो CSR 800 है ना, उसमें अगर ऐसे प्रोजेक्ट्स हो जाएं जो they use good science, no compromise on quality of science, no compromise on quality of science. We want to use the best possible science. And at the same time, we want to use this science to address the unmet needs in a possibly affordable manner, in a possibly simple manner. If it's not simple, at least affordable.
Yeah.
And that would be great. और बाद में फिर क्या बोला उसने? स्वांत है सुखाए, अपनी खुशी के लिए। अगर सबको आपके बीमारियां कम हो गई तो मुझे बड़ा अच्छा लगेगा। That's what I'm sure many of you will have the same motivation. सर हमारे काम से अगर सोसाइटी का भला होता है तो हमें क्या दिक्कत? तो देवेंद्र ये चीजें हम क्यों नहीं कर पाते हैं? ऐसे सिंपल सॉल्यूशंस क्यों नहीं डेवलप कर रहे? क्या कारण है? आपको मालूम है मनु प्रकाश ने क्या किया था? Anybody knows? सेंट्रीफ्यूज के बारे में, सिंपल सेंट्रीफ्यूज कैसे बनाया था?
यस सर।
बताओ जरा कैसे बनाया?
वो जो एक खिलौना रहता है ना बचपन में स्ट्रिंग से खींचते हैं उसको पेप्सी का ढक्कन डाल के, we made centrifuge of that.
कितने आरपीएम होते हैं उसके?
सर वो 28,000 या
2800 3000 करीब, ठीक है ना?
3000 आरपीएम तक पहुंचते हैं।
तो यार वो तो आपका डेस्कटॉप सेंट्रीफ्यूज बन गया ना?
यस सर, इंडीड।
उसमें अगर आपने ड्रॉप डाल दी तो प्लाज्मा को अलग करेगा, ड्रॉप को अलग करेगा, आपका ब्लड सैंपल जो है एनालाइजेबल हो जाएगा ना?
यस सर।
यार ये क्या मतलब इसमें इतनी अच्छी साइंस है। वो बच्चा IIT कानपुर का है। When he was in BTech, I had given him an award as a member of a jury. He had developed Lego blocks, where if you combine the blocks, you can write a program. तो बच्चों को अगर आप 4 ब्लॉक जोड़े, उसमें हर ब्लॉक में एक स्ट्रिंग था प्रोग्राम का। So if you join 4 blocks, you write a small 4-string program. That is what was his BTech project, for which he got an award from me. And then he went to MIT, worked with Neil Gershenfeld, another dear friend of mine, who is the director of Center for Bits and Atoms. तो उसकी लैब में उसने काम किया, वहां से करके वो स्टैनफोर्ड पहुंच गया। अभी तो उसने फोल्डस्कोप बना दिया, उसने सेंट्रीफ्यूज बना दिया, कितने सारे काम कर दिए। He uses high quality science for very low tech application, ठीक है ना? तो यार CSR 800 का मतलब तो यही है कि हमें साइंस के अंदर कंप्रोमाइज नहीं करना है, लेकिन एप्लीकेशन बढ़िया बनाने हैं, so that we may do PhD on anything, but at least some of our solutions must reach the society in as affordable manner as possible. तो कम से कम एक दिल में सुकून मिलेगा कि यार चलो एक समस्या तो हल हुई, एक छोटी सी बात को आगे तो बढ़ाया। Who knows that you might even publish a good paper out of it? For all that you know, you might. And if you publish a good paper, so much so good, your progress your career will grow further. In other words, please don't think that simple solutions cannot be published in the most prestigious journal. That's all I'm trying to say. Nature Communication में छपता है कोई पेपर तो उससे ज़्यादा फिर क्या होगा? So you can publish good finds. I would say that. I would certainly say that you can do a project group-wise or individually. I have no problem on that. I leave complete freedom to you. All of you are free. Arunima, you can take individual problem, you can take group. I completely give freedom. You can make intra-lab group, you can make inter-lab group, you can make group with non-CSIR students also. I don't care. I'm giving you full freedom. आपको किसी यूनिवर्सिटी के बच्चे के साथ लेना है ले लो, किसी आईटी के बच्चे को लेना है ले लो, मुझे क्या दिक्कत है? प्रॉब्लम सॉल्व करनी है हमको बस, उसके लिए कोई रेस्ट्रिक्शन नहीं है मेरी तरफ से. एंड आई कैन अश्योर यू नो लाइफ विल ऑब्जेक्ट. CSIR will also encourage you. पर्पस तो हमें अपनी मेधा को, we have to use our brilliance to be able to focus in a direction of solving a particular problem, or at least make a problem solvable. If you can't solve it, we annotate it. You describe it in such a manner that problem can be solved. Yes, one copy would be fine. Please submit it. And if you make some product and if you can share with me that, nothing like that, I'll be very happy because I will show it to you, to everybody around. I will be very proud publicizer of your project. Let me tell you that I think I know a little bit about communication. So I will communicate your ideas all over the world if you share with me solutions. That would be very nice. Okay, let's go further. So sometimes is there any comment on that? Presentation on December 1st, 2nd, 3rd. Please send a list to my colleague. Send it to either you send it to Namika or you send it to maybe education or sd@gyan.org. Let me write down so that we can and Megha and Bimbini will put together. Are you there around? .org. Or if some of you want to send to my email, that's not a problem. You can do that. So please send it there. We will put down the synopsis. We will put down everything in a sequence. I'll try to randomize so that all of you are ready on every day. And your turn can come anytime. So now this is interesting because we were in Sikkim along with my students. And we saw this. It was in the month of August, September, the break between first term and second term break. We normally go for Shodhyatra course. So the custom is everybody keeps some sprouted grains outside their window, outside their home on the window sill. So what people have to do, my tea is ready. If you want to see that, purple tea. And when let me show you my tea. So this is purple tea. I hope you can see that. And now I'm going to put some lemon, so it will become, this is the tea of Aparajita flower. And once you put the lemon in it, it becomes purple. From blue, it becomes purple. So this is the tea you can enjoy. Do collect Aparajita in your lab, around your lab. You may have, isn't it beautiful tea? Purple color tea. I'm trying to tempt you all. Do collect flowers from the shrubs, from the wild, and do make tea like this. Of course, after doing proper research, don't do mistake. Do collect literature. But this is the box of my flowers. I dry them and then put them. So coming back, I just wanted to, I'm so excited about small things of life because they give me sort of joy. So we were in Sikkim. And every house has to keep one kind of sprouted grain outside their window so that anybody can come and pick up a few grains. The custom is that you have to collect 9 sprouted grains from 9 households on that day. So supposing 3 neighbors of yours have put beans, simple broad bean. So then there's only 1 grain as yet. So 4th one has, let's say, lentil or moong. So now you have 2. But then 5th, 6th, 7th also have lentil. So you still have 2. So you have to go to as many neighbors as possible till you get 9 kind of sprouted grain. That's a wonderful way of renewing your neighborhood relationships. You take care. I mean, this is and there is randomization. You don't know how many houses you have to go to collect 9 different grains. This is a culture of Sikkim, but it is such a beautiful example of an institution. Once a year, say hello to your committee members and find out how they are doing. That becomes very nice, and you can then renew your connection. So there are not only technologies, but also institutions. I'll give you another example of institution. My colleague Ketan told me this. So, you know, there are bird feeding platforms in villages. In Gujarat, we have North Gujarat, Saurashtra, we have a lot of bird feeding platforms, Chabutra. And even on roadside, you will find some people throwing grains for pigeon, for birds and others. So here in this village, there was a cement platform, and on the top of it, they had put a clay layer. मिट्टी का लेप कर रखा था. So we asked the question, he asked the question, ये क्यों किया भाई? आप लोग तो जमीन पे डाल देते हैं, तो आपने जमीन की मिट्टी कंक्रीट के ऊपर सीमेंट के ऊपर आपने मिट्टी का लेप कर दिया, क्यों किया? You know what the farmers told? They said, sir, if we have left it at concrete, first of all, it gets hot during the daytime. Secondly, the beak of the bird will get worn out. The clay will not wear out the beak. Look at the way society cares about the beak of the bird, and therefore tries to offer grains on a platform where if it strikes, the beak strikes the platform, it will not get worn out, because then it will become difficult for the bird to pick up the grains if the beak gets blunted. Look at how careful our society is. And this is the kind of knowledge that we can find when we do encounter with these people. So let's go further. This I have told you. So let us look at something interesting. Have you heard about the name of Konrad Lorenz? Anybody? Konrad Lorenz का नाम सुना किसी ने? Ethologist थे वो, famous. He got Nobel Prize. Anybody heard him? There's a book, Biological Basis of Knowledge, which has been edited by Rupert Riddle based on Konrad Lorenz's work. कभी time मिले तो पढ़ना उसको. Beautiful book. So this illustration in which I'm going to show you is based on, let me show you the title of the book if some of you want to read. Rupert. Biological Basis of Knowledge. Biology of Knowledge. This is the book. It is not an easy book to read because it's very densely written, but let me show you that. So if you ever get a chance and you have time, read this book. So this is Biology of Knowledge, the evolutionary basis of reason. And it looks at whole range of insights based on Konrad Lorenz's work. Rupert Riddle was his student. And for example, he says, he looks at the cover of a microscope, skirt of a woman, bell flower, and the church bell. And he says, why does nature select bell-shaped curve? So such questions, very interesting questions. So the example that I'm going to show you is based on 3 sentences from the book that I read many years ago. Is one of my favorite, wait a minute. Yeah. So let's look at what it says. So there are, the nature is frugal, multifunctional, diverse, and resilient. And it says, let us look at form, feature, and functions. As we will, when we later on look at biomimicry, one of the questions is always, don't ask what you want to, when you ask a question, what you are doing, suppose you are making a cooling system, don't say I'm making a fridge. The moment you say I'm making a fridge, it stops your it restricts your imagination. You say, I'm trying to make a cooling system. Cooling system may not involve fridge technology at all. So what function I am going to perform is what we should think about, not what form I am going to select. Form can vary. Function will determine the form, and form will have features. That's how the design thinking can progress. So let's look at further what he did. So he said, okay, let me look at diversity. So Conrad Lorenz asked three things. Let us look at feather of all the birds. Please carefully see this picture. Feather of all the birds. एक मिनट देख लो इसको ध्यान से. मैं पूछूंगा एक सवाल अभी आपसे. Feather of all the birds. Let us look at. That's right, Sangeeta, you're right. So feather of all the birds. Then he said, look at fins of all the fishes. Look at fins of all the fishes. See carefully, I'm going to ask a question. Fins of all the fishes. Branches of all the trees in the world. Look at branches of all the trees in the world. Now comes my question. What is the range of the angle between trunk and the branch? Fish, body and the fin, body of the bird and the feather. What is the range? Anybody? What is the range? No. Well, you're not right. No, Sneha, you're not correct. हाँ भाई range बोला मैंने range.
It is 105
to 90
No.
degree.
Huh? Nandini, no. 40 to 80, no. Digvijay, no. How can you have the 360? What are you talking? Please look at carefully. Look at carefully.
more than 90 sir. More than 90 105 and above.
Sorry, again repeat.
105 and above.
हाँ, कौन था ये भाई? आवाज बताओ, अपना नाम बताओ.
Matian Noor. It varies in all. It varies in all the forms.
So what you can capture all the forms. If I stand before you, let's say I'm a tree, so I cannot have a branch just sticking to my body, my trunk, isn't it? So let's say 5 or 10 degrees and 90 degrees. Because when you say obtuse, actually you have to use one axis only. So then all branches can be explained. And all the diversity of nature can be captured between 5 to 90. All trees, all fins, fishes, all the birds. So what does he say? He says nature is very parsimonious. Nature is very parsimonious. It has few designs and it plays with them all the time. I love this sentence. It made such a deep impact on me. Nature has few designs, it plays with them all the time. It's very parsimonious. Parsimony, you understand? When you use a simple expression or simple resolution for a very complex phenomenon. No, 0 to 180 नहीं होगा बच्चे. आपका branch ऐसे थोड़ी आती है कोई कभी भी पेड़.
Hello.
50, 5 to 90 is okay. 5 or 10 to 90 is okay. That is the range within which all the diversity can be captured. Now the question that arises is, can we figure out these simple phenomena that underline, you know, the golden ratio? The ratio between, let's say, the shoulder and the neck. And this is a golden which Leonardo da Vinci studied a great deal. Yes. So we have, there's a very interesting book some of you might like to read. Abdul Mateen Bolo. Please go ahead. Go ahead.
Yes, sir. Actually,
अपना वीडियो ऑन कर लो, अगर कर सकते हो तो करो. अब्दुल, हाँ, let people see you. मैं भी देखना चाहता हूँ तुम्हारी शक्ल.
Sorry, sir. It was a mistake.
अच्छा कोई बात नहीं, चलो बोलो, आवाज दो, आवाज तो आ रही है, बताओ. बोलो
No, sir,
बोलो.
nothing, sir.
अच्छा अच्छा अच्छा. I saw your hand raised, so I thought you were saying something.
Sorry, sir,
Okay,
sorry.
no problem. No. So the question that arises now is that how do we begin to see these simple patterns? Do you know that no two crystals of snow have the same design? You know that? You know that?
Yes, sir.
You know the shape of the crystal of snow? कैसे क्या होता है, क्या दिखता है, आप जरा बताएंगे मेरे को? क्या होता, कैसी शक्ल दिखती है क्रिस्टल की? हाँ भाई? Can you tell me one word? How does it look like? बताओ बताओ बताओ, before I show you. Anybody who has seen this snow crystal in microscope? नहीं, hexagon तो hexagon is element of that. हाँ बोलो. आपके जो ईयर रिंग्स है ना बच्चे, लड़कियां जो पहनती है ना कान में बुंदे, अब देखो जरा, दिखाता हूं मैं आपको, देखो जरा, आप भी कहोगे कितने सुंदर है ना? Are they beautiful?
This is what we see in Disney movies, sir.
Now the question is, no two flakes are alike. Can you believe it? Look at how unique the nature has to be. Tons of snow is lying on the mountain, huh? Tons and tons and tons. Icebergs हैं पूरे के पूरे. और कितने बिलियन ट्रिलियन पार्टिकल्स होते होंगे एक छोटे से आइसबर्ग के अंदर, और सभी के सब अलग हैं. There are no two particles are alike, no two crystals are alike, no two snowflakes are alike. There is something in this. Nature's ability to produce originality, diversity, and an ability to use this diversity by modifying the shapes, forms, connections, design in such a beautiful manner. अब इससे ज़्यादा तो variety कहाँ मिलेगी हमको? When I'm making a case for learning from nature, what I'm trying to say is form, feature, function. अब इसका function क्या है? I don't really know why would nature do that, but perhaps for the flakes to interlock with each other, to give a density to the snow, for whatever. I don't know, but then why did nature have to be so unique? And mind you, no two mango trees, no two pigeon, no two human beings, no two dogs, no two birds are alike. ठीक बात है? You agree? If that is the case, then why should students of my class not be unique? फिर आप लोग सब unique काम क्यों नहीं करेंगे भाई? I don't want you to do anything which is passé, which has been done before. थोड़ा हर एक से मेरी उम्मीद है. Everyone is unique, so are you, and therefore your contribution has to be unique. I wouldn't take anything which has been done before. Please, for God's sake, don't present a project about something that has been done before. Please don't do that. Bring out the uniqueness in what you're doing, because you are an absolutely beautiful gift of nature. आप सब unique हैं. आप सब unique हैं. तो आपसे मैं उम्मीद करता हूं कि आप लोग unique ideas present करेंगे. इससे कम तो स्वीकारी नहीं है, इससे कम तो मैं एक्सेप्ट नहीं कर सकता ना, क्योंकि अब आपने देख तो लिया नेचर कितनी डाइवर्स है, और हम सब तो नेचर के पार्ट हैं. तो इसलिए थोड़ा प्रेशर डालना अपने ऊपर भाई बच्चों. Put some pressure on you. I cannot create this pressure. You have to create this pressure yourself. The best comes out when we create, when we increase our expectation from ourselves. देश में सबसे बड़ी प्रॉब्लम हमारी सोसाइटी में है ना, हमारी एक्सपेक्टेशन हमसे कम हो जाती है. We reduce our expectation from ourselves. This is the greatest tragedy of our time. मुझे सबसे ज्यादा दुख होता है अगर किसी एक बात से, तो वो यही है. People don't want to go expect more. So this is how we walk in different parts of the country. We search, we spread, we celebrate, and we sense the unmet need. We search, we spread, we celebrate, and we sense the unmet need. जाते हैं दूर 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 जाते हैं, कहीं पानी है, कहीं पहाड़ है, कहीं आइलैंड है, कहीं कुछ है. And we learn, as I said, teacher within, teacher around, teacher in nature, teacher among the common people. And we meet such people all over the country. All over the country, we have met such people. Can you imagine कि कुर्ता विदाउट ए स्टिच, एनीबडी? कोई तरीका है ऐसा बनाने का? कपड़ा का कुर्ता है जिसमें स्टिच नहीं है कोई भी, है भाई? पॉसिबल है?
यस सर।
कैसे बनाओगे?
क्रोशेट।
कपड़े का? मैं स्वेटर नहीं बोल रहा हूँ, कपड़े का कुर्ता बोल रहा हूँ। बोलो, हो सकता है?
दे पुट क्रोशेट सर, दो स्टिक लेके वो करते हैं ना, उसको क्या बोलते
वो तो कपड़ा तो नहीं होता ना, वो तो क्रोशे का वर्क होता है ना।
हैं? हाँ।
मैं क्रोशे थोड़ी पूछ रहा हूँ, मैं कपड़े का पूछ रहा हूँ। मैं दिखाऊंगा भी आपको एक कुर्ता ऑफ ए सिल्क विदाउट अर्नमा। आई एम आस्किंग अबाउट, कैन यू इमेजिन लाइक आई एम वेयरिंग दिस कुर्ता, ओके? दिस कुर्ता हैज ए स्टिच हियर, स्लीव्स हैं, ठीक है? स्लीव्स जो है, कॉलर भी है। अभी हम खाली स्लीव्स पे ध्यान देते हैं। तो स्लीव्स और इसके अंदर कोई बीच में जॉइंट है ना यहाँ पर एक? आप सोच सकते हैं कुर्ता बिना जॉइंट का?
नो सर।
और यहाँ भी जॉइंट है ना, ये स्लीव के यहाँ भी एक सिलाई है ना, ये वाली, है ना? ये भी सिलाई है। चलो देखो क्या होता है। करना मेहर हैं, उनकी पत्नी, दोनों जने के मैं मिलाता हूँ आपको। उड़ीसा में बड़पाली मिले, दिख रहा है आपको पिक्चर? ही इज करना मेहर, शी इज हिज वाइफ। उन्होंने ये कुर्ता दिखाया है मेरे को बिना स्टिच का, कहीं स्टिच नहीं है इस कुर्ते में, वीव किया है, वीवर है वो। कैसे किया होगा भाई? आप लोग साइंस एंड टेक्नोलॉजी की बात करते हैं, जरा मैकेनिकल इंजीनियर्स भी हैं आपके बीच में, टेक्सटाइल के भी लोग होंगे, कुछ ना कुछ फैब्रिक्स के भी होंगे, नेचुरल फाइबर पे भी काम करते होंगे एम्प्री में। देखो जरा इसने क्या किया है। बरीपाली बरगढ़ जिले में, उड़ीसा में, कोई स्टिच नहीं है इसमें, कोई स्टिच नहीं है। अद्भुत, अद्भुत। दिस इज द ब्लेसिंग ऑफ आवर शोधयात्रा। हम ऐसे लोगों से मिलते हैं जिन्होंने कुछ, हम दे वाइडन आवर horizon of thinking, they expand our imaginative space, landscape. जो चीज सोच नहीं सकते वो लोगों ने कर दिया। अब आप सोचते रहिए कैसा लूम बनाया होगा, कैसे वीव किया होगा। ये प्रॉब्लम आपकी है, आपको सोचना है। No, there is no, just look at the way this whole thing has been woven together, woven together, woven together. So the question why I'm saying it, अभी मुझे याद आ गया तो मैंने कहा आपको दिखा देता हूँ, because I want you to appreciate that when we talk about science and technology, there are unique facets of solving problems which we encounter during our walks. Never once has it happened that we will go on a walk and not be surprised. In fact, I always argue, the day you are not surprised, you have not lived. I kept on repeating this. I've said it many times before. I'm going to say that again today. The day you are not surprised, you have not lived, you have existed. What is the meaning of surprise? My God, I didn't know this. The moment you say, my God, ये क्या हुआ, ऐसा तो कभी देखा नहीं था. That surprise creates curiosity. That curiosity creates uneasiness, बेचैनी, बेचैनी के बीज बो जाते हैं फिर वो डिस्कवरी होती है जो और किसी वजह से नहीं हो पाती. That restlessness which comes out of the curiosity which has been triggered by something that has surprised you, something which has shocked you sometime, something that you cannot imagine, generates a solution. And the challenge is to look for such breakthrough solutions. Anything less is all right. It's just a passing. So let's look at further. So this is a handloom in every house you have in Northeast. There are several students of ours who are from Northeast. जमीन के ऊपर बना लेते हैं, घर में बना लेते हैं, कहीं भी लूम बना लेते हैं, पूरे नॉर्थ ईस्ट में. बहुत ज्यादा इनोवेशन हमने किया नहीं उनके लिए. दैट्स अनफॉर्चुनेट. चाहे वो CMRI हो या टेक्सटाइल इंस्टीट्यूट्स हो या IITs हो, किसी ने भी बहुत काम किया नहीं जो उनके पास पहुंचे. So they are using age-old technologies. Some people have done. For example, Deepak Bharali has designed a magnetic bobbin. Bobbin, you understand? When you put the thread like this, there are bobbins which make the thread go into different designs. The booty बनाते हैं साड़ी के अंदर, आपने देखा होगा booty होती है ना, तो उसके पीछे धागा कटा होता है कई बार. The thread has to be cut on the back side of the sari from one booty to another. So that thread goes waste. Whereas what Deepak Bharali did with the help of Dr. Das, A.K. Das, who's director at NIT Imphal and also professor at in IIT Guwahati, he helped him. He went to Plastic Institute, he went to Gurgaon. He spent 5-6 years in solving that problem. The idea he had got it, that I want to make magnetic bobbin. Now he sells it about 4,000 to 5,000 rupees and is doing well. So that was a breakthrough in the weaving technology, when you would save some few seconds every time and the thread was not wasted anymore. So you moved the bobbin from one booty to another without wasting the thread. That's what he did. Like that, there have been some such modifications that have been done. I'm just trying to highlight that there is so much aid, so much scope for us to extend ourselves. The vegetative colors, for example, and where I may have vegetative colors knowledge, doesn't is there. Now, just now, our friend was mentioning about filters. So this is the filter we found in Dhimaji. ये सब तीनों filter हैं वहाँ के. तो उसमें वो sand, pebble, charcoal वगैरह डाल दिया. The water which comes out looks clean. So we filled up this water in a bucket, in a bottle, and we started walking. When we shook the bottle with our movement, the water became brown. So they were dissolved iron. If iron content is more, it leads to liver disorder, diabetes, arthritis, etc., etc. So we need a filter which will remove this iron content. Some of you who are interested in the subject might take it up and do a research and give us a paper on what kind of materials, locally available materials, low-cost materials they could use in Dhimaji. Dhimaji, incidentally, is the place where Ulfa was born in Assam, that insurgent organization, unfortunately. तो जब हम कोई चीज की बहुत दिनों तक इग्नोर करते हैं ना, तो अशांति फैलती है. So we have to bring peace and order in our society. So this is one way. These are there, but these are not good solutions. Another thing that we saw in a Dhimaji Shodhyatra only, we went to village Bisamari, and one village had so many different designs of drills for shaping wood. वो देख रहे हैं पाया बना रहे हैं खाट का, the legs of the cart. So there is a huge big wheel of 6 feet diameter. What is the common thing in all of these? Can you tell me in simple terms of energy transfer? What is common? What is the concept? What is the way energy is being transferred?
Supply wheel.
Which kind of gears are being used? From which gear to which gear? From large gear to small gear, correct?
Yes, sir.
Charkha also has from large gear to small gear. The glass blower also uses large gear to small gear. My friend Ajay had told me once, very interesting insight. He said most of the indigenous technologies, including Ghani, oil pressing machine, water Persian well, all of them use transfer of energy from large gear to small gear. The moment motor was invented, you could transfer energy from small gear to large gear. Correct? In a watch, you use transfer energy from small gear to large gear. So modern technologies use small to large. Traditional technologies use large to small, because the purpose is to increase the RPM. And in the absence of motorized device, the only way you can increase RPM is by using a large gear. So it's very interesting. Now, how do you make them more efficient is the challenge. And that's what the challenge we are facing. In Mizoram, we saw something very interesting. I will call Mizoram as the water harvesting capital of India. No house there, no house, not a single house I found which did not have water harvesting structure, rooftop water harvesting structure. So here they collect the water in this, and then from here it comes through this bamboo into this tank. Here, and then here it comes. Almost every house has rooftop water harvesting structure. Earlier, people used to live in the valleys. During insurgency in late 80s, they were all brought on the higher altitude. Now, when they were brought to higher altitude, वहाँ तो पानी नहीं था. So this is a practice which evolved only in the last 20, 30 years, that is, or 40 years. Everybody started collecting rooftop water. So, large number of such examples. All of these are, look at this, water is going here. Rooftop water, makeshift, different kinds of solutions. We could do better. Now, this is an exact example we found in Mizoram. यहाँ से एक drop fizzle कर रही थी from the tap. This man would not waste even that drop. He put a canister here so that even that drop is saved. There are people who are very conscious of a drop of water. Very conscious. Many of us are not. When we brush our teeth, the tap keeps on, isn't it? Sahi baat hai? Anytime this happens. So we will have a break for 5 minutes, 7 minutes break, maybe 7:10 we will meet. Have just refresh yourself, stand up, walk, and get refreshed. And we'll meet at 7:10.
कैप्सिकम बोलते हैं इसको, जो भी आप तो छोटी वाली टिकट पहन चाहिए।
All right, welcome back. Switch on your videos, please. All right, so we will look at a few more examples and then we go to biomimicry, which I'm sure all of you are very familiar with, but still. This is a small example in Mizoram where we found that when you cut wood, the drill becomes hot. So he had put a drip of water to cool the cutter so that its efficiency goes up. It would not become too hot. Here, this is a kid we met in Ranchi, Muhammad Sajid Ansari. His father was a vendor in a cart. He used to.
So please share the screen.
Oh, okay. Sorry.
Thank you.
Yeah, I forgot sometime. Okay. So I was talking about, this is the example where I said that in Meghalaya, they were using a drip of water, drop by drop. It will cool the cutting gear for wood. So very simple, but very interesting solution that we just came across on the roadside. And this is another boy we met in Ranchi, Muhammad Sajid Ansari. He was in class 7 at that time. And he observed what most of us have observed in our home, which is that we clean the rice before cooking. क्या करते हैं हम लोग साफ करते हैं ना उसको हाथ से और कोई तरीका है क्या? Is there any way that we have of cleaning the rice at home? Other than taking the rice in a thali and then trying to pick up inert material one by one after sieving it, of course. Anything else that we do? Anybody? Can you imagine a design? Can you design a small device, low-cost device, by which we can separate the rice from the inert material? Anybody? So this boy did it. He made this. So there's a motor in the upper part of the device. He put the rice on the top. There are two different outlets, and the heavier particles go, you drop first, the lighter particles go farther. And that's how they do the separation. Incidentally, this was the technology which was also used in a Tata chemical plant in Bhrara for making salt. And a worker gave a suggestion that when you take the salt out of the plant, put a screw gear in the outlet of the salt. So just as in clay, in a lake, the finest particle is at the bottom, that is clay. The thicker particle is on the side, that is silt. And thickest particle, that is sand, is on the top. So that's how they move. It's a simple physics, that lighter particle will go farthest. So using the same principle, they did a separation of salt, and in this case, separation of inert material from the rice. Very simple but precise physics being used to develop a solution. This class 7 boy who did it. This we have talked about. I'll skip these. And I'll come to this slide, which is how do we learn from various innovations that come? This is true for any one of us. Any innovation that you have. There are 4 levels of learning: artifactual, analogic, heuristic, and gestalt. Artifactual means from this to this. So let's say Metal Sand developed a bamboo windmill in Assam. We took it to the Kutch in Gujarat from east to the west and used it for pumping brine water for making salt. Windmill to windmill, some minor changes in the design and material. Analogic metaphor. So the Swiss engineer looked at cockle burr, made a Velcro 50 years ago, 1950s. Analogy. He used it metaphor. Heuristic models of thinking. So if you want to use a good heuristic, the example again of windmill-based water pump, slower irrigation, less leakage, seepage of nutrients. Fast irrigation, more loss. So when slow is better, there can be different kinds of heuristic which can be used for learning about innovations. So we don't replicate innovation, we replicate the heuristic. For example, one farmer, as I told you maybe before, I'll give example of the same. One farmer said that, all the plants which animals don't eat are potential source of herbal pesticide. Why animals don't eat? Because they're toxic. What do we need for controlling pest toxicity? That's a very good heuristic. A underlying principle, natural sources of toxicity. You can use it for various purposes. Gestalt is a configuration of technology, institutions, culture, etc. So there can be different levels of learning from concrete to abstract and from artifactual to Gestalt. This applies to all fields of knowledge. This applies to all domains. You can use them wherever you wish to. Any question on this? Any comment on this before we proceed further? Anything that you want to add or subtract here? Any other model you want to add? Anybody? Anybody wants to add anything to or subtract here? Any other model of learning? Artifactual, metaphorical, heuristic, and Gestalt. Anything else comes to your mind? Any other learning principle? The drop of water story was metaphorical. Anything else is? Yeah, but learning from nature at 4 levels. I mean, you can learn same to same. You can learn analogically or metaphorically. You can learn heuristically. So when we said that no two snowflakes are alike, what is the heuristic? Heuristic is that similar principles of hexagon, as you said earlier, or different kinds of angular arrangement can create different variety of patterns. A lot of diversity can be generated by simple principle, simple change in the angle. So good heuristic. Yes, Mamta? Or anybody else? Probably one can add paradoxical thinking that many times you learn by putting contradictions together. So opposites. If you look at normal distribution or any distribution and you take the two tails of the distribution, Buddha told us compare and contrast. It's actually a good heuristic. Again, it's not a different dimension, but nevertheless, it's a good heuristic to look at contradictions. What else would be the way we can learn? Any thought comes to you? Perhaps, I don't know whether that's a separate principle, but simultaneity, I mean, now we are talking about biome, the gut biome, as a autonomous system of, now people say gut has a separate brain of its own, which is different from our nervous system. That's a recent finding, that gut can do things without using nervous system here. So gut has a brain of its own, which means autopoiesis can be what I discussed earlier, that where learning can be through self-designed, self-correcting pathways. So if we can learn how healing takes place, for example, self-healing processes. So there can be self-correcting autopoietic systems that can probably be added here. Okay, let's go further. But if any one of you has any other thought, please do write to me. I'll be happy to hear from you, because this is something I've been thinking for some time. What are the gaps here? So we have looked at the innovations from children. I will not go into further. Some of these examples we have seen. I want to just mention this, which we will discuss in the next class. Forms of incentive, material, non-material, individual, collective. Please do think about different ideas, and we will do an exercise in that class where you will have to come out with different kinds of incentives, which may or may not have been tried so far in CSIR or anywhere, but which we can try. So we will create a long list of ideas where a portfolio of incentives can be designed to get the best out of all the young scholars that we have. So how do we do that? How do we do that? This is an example. I think I gave you how pooling of the best practices. So we got 6 communities, which gave us 6 ways of healing skin disease, put it together, pooling the best practices, created this product, which we licensed to a company, Troika Pharmaceutical. And all the 6 communities were invited at the launch. They get royalty every year. For 20 years, they will continue to get a money order from us for the benefit that they get from the royalty. So we also developed the G2G model. From all these countries, the innovations were marketed. In Peru, Uganda, Ethiopia, Philippines, Singapore, Turkey, Brazil, whole range of this. And there are many countries from where we received queries, from Congo, from Benin, from Nigeria, Australia, Turkey, Netherlands, Thailand, Bangladesh, Rwanda, for different solutions, different places. They discovered us, we didn't know them. So sharing has this advantage. When you share your data of innovations, people from around the world write to you and seek ideas. And that's very powerful way. That's why, yes. So I've shared this with you earlier. So I will come to, this is the way we designed the 5 functions of ecosystem: scouting and documentation, value addition and product development, enterprise and business development, IPR management, dissemination, and information technology application. No matter where you work, these are the 5 functions that you will require for developing an ecosystem. We did it in NIF, National Innovation Foundation. We can do it in any place. In any lab, you will need all the 5 things to be done for building a value chain from idea to innovation to product to process to value-added process to business, finance, IPR, and so on. So let me stop here and go to the biomimicry for some time. Can you give me some good examples of biomimicry before I show you some examples? What are the different forms we learn from nature? Just type out or speak up, unmute yourself and tell me. Give me example of biomimicry. Either you have used in your lab or you may like to use.
So the most basic example would be that of a Velcro tape.
Yes.
and also the aerodynamic design of the
Like a
planes and
bird.
ships.
Look at certain birds or fishes.
Yes, sir.
And their body. Yes, that's right. So
Sir,
they are obvious.
sir,
And what else?
So also I read somewhere that the beady structure of the lotus petals,
Correct.
I mean, it doesn't gather any dust particles or something that was used to create dirt-free paints and stuff like that. That beady
Correct.
structure.
The Volvo, I was doing a program for Volvo in Shanghai, and there I mentioned the paint that they had developed, which had hydrophobic property. So water will not stand, like a lotus leaf, will not stand on the paint. It will be repelled or it will be pushed over, so that paint will stay longer. So you're right, lotus leaf is a good example of hydrophobic or self-cleaning surfaces, you can say. What else? More?
So this research didn't like make it to the market at large.
Which one?
But some people did test this property of the lotus leaf for making a tube of toothpaste, because they found that generally when we make any tube, I mean medicinal tubes or anything, ointment tubes, we are not able to extract the entire material out of the tube.
Yes.
So one group, they studied this structure, beady structure of the lotus leaf for making a tube. So that ways it the entire content of the tube came out. But I didn't see it being applied in the commercial market, but I read an article about it.
Well, self-cleaning surfaces have been developed. So this is a paper I'll show you just in a minute. So, yeah. These are, let me show you this example. So if you look at this lotus leaf and what are the things that it inspired, let's see. Maybe I should put the
lotus, a symbol of purity in many cultures.
Let me put the sound on. Yeah, sound is okay. We're able to see that.
This flowering plant grows well in shallow pools and muddy ponds. Its reputation is well deserved because the leaf of the lotus does not stay dirty. In grimy natural conditions, the lotus appears unfouled by its surroundings. And science has figured out why the lotus stays this way. It's been known for a long time that the leaf repels water. Scientists call it a hydrophobic surface, simply afraid of water. In fact, the lotus is remarkable because it's one of a few plants that are considered to be super hydrophobic. This means that when a water droplet touches it, the water beads up into an almost perfect sphere and can easily roll off the leaf. This superhydrophobicity doesn't happen because of just the chemistry of the surface. It happens because of the shape of the surface on the micro and nano scale. As we get closer, we see a beautiful green landscape that isn't smooth but bumpy. This rough texture prevents water from wetting the surface. Now, using an optical microscope, the waxy bumps and the gaps between them become clear. Each bump is about 0.01 millimeters wide and about 0.015 millimeters high. The attraction between the water molecules is greater than the water's attraction to the small bumps and gaps, and so the water forms little beads. If the lotus leaf only had these micro bumps, it would still be hydrophobic, but the lotus is super hydrophobic. The extra boost comes in at the nanoscale. Remember, a nanometer is a billionth of a meter. Now that we're using the scanning electron microscope, we can dive further into seeing what's on these waxy bumps. As we get closer, we don't see bumps with a smooth surface, but a roughly textured surface. Closer still, the bumps look fuzzy. In fact, each bump has thousands of tiny nano-sized hairs. Just like the micro-sized bumps, the nano hairs create air gaps, and once again, the water molecules have a greater attraction to each other than to the hairs and nano-sized air gaps. It's these hairs that make the lotus so effective at repelling water and keeping itself clean. And what's amazing is science is trying to mimic these types of structures in different things. For example, researchers have created hydrophobic fabrics that repel water, self-cleaning coatings, and super hydrophobic surfaces that can be used to channel minuscule amounts of water through sensors to detect impurities. What other applications can you think of?
So they have looked at dust repelling coating for spacecraft, technology from a specialized unique surface that keeps water bottles free from mold, stains, odor, stain-resistant fabric finish, and overhead structure repel waters. So all of these are various examples. I will stop here. You don't. Yes, Ashish, you wanted to say something? Go ahead.
Yes, sir. Sir, I would like to bring out one important biomimicking example, the honeycomb structure that we see.
Yes, yes.
It is used in almost like there are infinite number of possible like applications, but one of the best one which I have seen in technology is the use of honeycomb structure for cell towering in mobile communication. They use the adjacent layer cell. They define the cell sites as a honeycomb structure itself.
And you know, for packaging material, when we use the hexagon, when we use packaging material, the honeycomb structure can tolerate a huge amount of weight, right?
Yes, correct.
So
exactly.
Corrugated material.
Yeah.
Yeah. Yes. So yeah, Mamta, go ahead.
One more example of biomimicry is whale swimming. That is same as the turbine movement.
Mamta, I missed your point. Please again.
Yes, sir. The one more example of biomimicry is swimming of whale, and that is exactly same like wind turbine movement.
Correct. There was an article in the last Sunday's Indian Express also about slimy nature of the fish, the slimy material, what is inside our body called as mucus. They have a mucus kind of material on the surface. So what does mucus do? You know that, isn't it? Some of you must be knowing. So it has a function of keeping us safe from certain infections, certain microorganisms. So there are healthy organisms, and then of course there are bad organisms, and the mucus helps us to keep it away. It tries to take it out. So that's another case where we can create such materials that can create an antimicrobial surfaces, which has been tried. If you remember, we talked about titanium dioxide nanoparticles are mixed with the paint, but in Kashmir they had used jute fiber with the clay to keep the surface safe from fungal attack and bacterial attack. So yes, you're right. Any other example? Digvijay, you were saying something about silk. Go ahead. Anybody else wanted to talk about any other biomimicry example? Less obvious, less common? Hummingbird, yes. To helicopter, okay. In fact, it can hover over a flower. Even bees do that. You know, dance of bee has been used for signaling purposes to study in the electronic areas when they try to see how does one bee communicate to others that this flower has a nectar already picked up. So don't come and waste your time in picking up the nectar from the flower. So they give a signal to other bees that no point in wasting time here. So they have a particular kind of wiggle dance, which communicates to the other bees message. So there's a signaling system among the.
The same as with the birds' navigation system, the way they navigate back to the nest. So that is also the same used for signaling.
Correct. Very right. Very right. Because they have what kind of remembrance they do. And the migratory birds, for example, from Siberia, cranes come to India, you know, such a long distance they travel. And they come to the same point every year and then they go back thousands of miles away. So people have been studying how they keep track without a compass, without a navigation system. What is their biological, neurological navigation system which makes them to go same place? So there is a huge research done on mapping not gene mapping, but mapping genes. The genes which help map lobster eyes. Very good point, Manjeet, for telescope. Yes, that's a good example. So we need to really think more. Give me more examples of biomimicry. A few more examples.
Good evening, sir.
Yes.
Sir, I have heard about yaks. Yaks का जो fur होता है, they have been studied and it has been used for armies to make innerwear so they can bear in low temperatures, such as Siachen glaciers. They can survive there.
Correct. So, you know, there is a very interesting institution. Now you mentioned yak. So in Bhutan, I did a study long time ago, 85, 86. So when cattle go up, yak come down.
Yes.
But yak must vacate the pasture a month before the cattle come, because otherwise there will be no grass for the cattle to come. So around cattle will go up from the basin, from the base to the 4,000 feet. Yak will come, let's say, from 6,000 to 8,000 to 4,000. So there is a place where they can meet. If they meet, then diseases can be transferred from cattle to yak. So how do you tell people that time to go back, cattle is going to come in a month's time? They don't have a very precise calendar and things of this kind. So when rhododendron flowers, that is a signal that yak should go up now. And it flowers a month before the cattle will come for grazing. So even the eco indicators, as they influence, they capture a very complex ecosystem changes. The flowering of a plant depends upon the moisture, the temperature, the light, and so many factors. So all of them are captured in this signal, and this signal then is used by human beings, in this case pastoralists, yak herders. Another example from what you said just now, we came across this example in 77, 78, 79 in Rajasthan. The wool that grows on the mane of the camel. Now, people studied that the hair on different parts of the body have different properties. So the one on the mane, on the, so to say, backbone of camel, are very hard. And they found that when they made a rope out of it, it was very anti-corrosive. In the coastal areas, in the shipping yards, they were using rope made of that fiber. So somebody got an idea and they made carpets used as filters in the oil refineries. Now look at that. I mean, where is oil refinery? Where is camel? Where is the hair? Where is which particular part of the hair, body hair, and the property of that because of its anti-corrosive nature. So many times people also observe unique properties. And nature, of course, produces variation, but we have to then select some kind of features and functions from that variation. And that's how the biomimicry or natural analog have done wonders. Have you ever thought about, I'm going to ask a very strange phenomena, but very real phenomena. Mishti dahi in Bengal, West Bengal, many of you must be familiar with Mishti dahi. It's a sweet curd, sweet yogurt. How do the people maintain the culture of that yogurt unaffected by other organisms, other bacteria for years and years? How do they keep that in room, at the room temperature? It's open. Why doesn't it get contaminated with other kind of bacteria? In lab, it's so difficult to keep bacteria away. You keep any petrodation, it will get infected by aspergillus and whatever have you. But this Mishti dahi culture doesn't get affected. Why? Anybody? Any Bengali or North Eastern fellow? Or you all like Mishti dahi? कैसे होता है बताइए? Yes, Ashish, you know that?
Sir, I think it is. I'm just taking a guess, but I think the microorganism which is used to make this Mishti dahi is a faster growing one than the other ones present at the room temperature. So they are using the same ingredients. So that is why that one is only getting propagated and multiplying, not the other ones.
My question is, if you ask such a question, then you can get some interesting answers. So Streptococcus salivarius, Thermophilus, Lactobacillus acidophilus, Lactobacillus delbrueckii. There were 4 different cultures that CFTRI scientists in 2000 isolated from Mishti dahi, published a paper in 2000. They must have done it before. Journal of Food Science and Technology, I can show you that. So my question is that why wouldn't we do research on that? And this is an example of, I would say, very good science, good research. And so they found casein stabilizer matrices showing defined distribution of lactic acid bacteria in yeast cells in the experimental samples. So they looked at the Mishti dahi is sold in around Calcutta market for analyzed for microbiological property. And wide variations can be attributed to manufacturing condition, type of starter culture used. And therefore, you like some shops Mishti dahi better than others, you know, that particular culture. But the question is that they have maintained these starter cultures in the pure form at room temperature in the room open conditions for such a long time. There are families known for maintaining this culture, microbial cultures, mind you. We need to learn about that. Why? How is it that these cultures remain pure for such a time? So my question is, friends, that we need to go into the basic science of this. And if you go into basic science, you might discover a new concept, a new way of self-repelling process, which microbiology may or may not know about, by which certain cultures can keep the integrity of their own ecosystem without letting any other organism infiltrate. Isn't that unique, strange, but interesting and inspiring at the same time? How did our people discover those cultures, first of all, which would not contaminate? Same applies to jalebi yeast, for example, which is used for making jalebi or different kind of. France has in Paris, they had a study, there were 240 kinds of breads. And they looked at the yeast of these breads and did a study, some scientists, to try to find out how certain families had maintained certain yeast for making this particular bread. In wine, there are yeast cultures which certain wine have different aroma, and they have maintained, people who are wine tasters know that wine of a particular garden, even a small garden, can have a global market. So there is a very long tradition of maintaining something in nature which is counterintuitive, which is to maintain purity of yeast, purity of bacteria. In some cases, fungi. In Northeast, there are fermented foods. Sharing, you might know certain fermented foods. And these foods get a particular taste because of a particular kind of microbial culture. And why only that culture? Is it host specificity? What is that? Is it, but if it is host specificity, then different kinds of milk should mean different kinds of contamination. That doesn't happen. When you make a yogurt even at your home, you get a good yogurt, isn't it, if you have a good starter. So it is not that only Mishra Dahi has this property. So we have done all these experiments, but we have not looked at the science behind it. I'm asking these questions because I want you to push the curiosity a few notches above where it ends. Then somehow we take it for granted and move on with the life. Then how will great discoveries take place? So if we are trying to talk about science, which is inspired by nature, produces wonderful technologies, and at the same time advances the science. So for instance, we published a paper which was published in Science a long time ago, where they found some vessels of wine in Egypt 2,000, 3,000 years ago. And they analyzed the residues on the vessel in which wine was made. And they identified some compounds which were phytochemical compounds, which were used to make, for the alcohol extraction from the molasses or whatever they had used for making wine. So they could predict what kind of plants may have this compound, and so what could have been the ecosystem in which this wine was made. Just look at the cross linkages, connections. I think this is the kind of connections that we need to make. You know, intelligence is nothing but connecting the unconnectable. Please understand. There's one simple definition of intelligence. Connecting the wait a minute, what is this? Connecting the unconnectable. So if you can connect things which don't seem to be connected, you have made a breakthrough. Simple thing. And to look for those connections, we need to listen to people, we need to look at the nature, and some good solutions can emerge. Let me just show you a few. Sangeeta, the question is, lactobacillus is also very useful for our gut. Our gut has a lot of organisms. If lactobacillus was capable of avoiding other, then our gut will lose all its diversity when we take milk. That doesn't happen. Ask counterintuitive question. So naturally, there is something more than that. And we need to figure that out. And this is something that intrigues me, and I think we should get intrigued by certain phenomena that our society has been able to, and not our society, most societies have been able to develop. Just that we are not asking those questions which some people ask and therefore make big discoveries. But I'm saying there is a very basic science question here, and there is a very applied science question here, and there is also a very interesting technological question here. So we can get into many questions from this. Now let's look at some other examples. I will leave, you can continue to think about some examples. I'd like to show you some examples. Few examples that you may or may not have come across. So this is a very interesting energy efficiency, how to create flow without friction. So there are many flowers of this kind. There are many worlds of this kind in nature. And from the point of view of movement of fluid dynamics, interesting. In fact, in China, once somebody used this shape for cleaning the grains. So they put a whirl of this kind, about 5 feet high, 6 feet high. They put the grains on the top, and at different point, they took out the different sized particles. So this is possible to use this shape for different kinds of separations also. We have discussed that. The termite mound, for example, is one of the best air-conditioned system. So how to create sustainable building? People are trying to learn from termite mound. They maintain uniform temperature. They maintain much cooler temperature than around surrounding. How do they do that? So this has been a question that has been bothering scholars for a long time. This you already mentioned about. This is very interesting. How to sequester carbon the lungs itself collect carbon. Oh my God, that's interesting, because and then they get damaged in the process, because those who smoke, their lungs get damaged. So what functions you want to perform? Don't ask what you want to design, but ask what you want to do, which means cooling system, not conditioning systems. You can cool through desiccation, you can cool through dryer, you can cool through heat exchanger, you can cool through evaporation. So there are so many pathways the moment you talk about function rather than form, that our mind can be opened. But many times we get stuck to the form rather than function. And that's a very interesting lesson. There are many things that are not mentioned here, such as evaporative heat exchanging, geothermal energy for cooling. 4 feet below the ground, the temperature is lower. So one of my colleagues had done that, Shodhyatra. He took a water pipe under the ground and then brought it, and then with a fan, he will pump the cool energy, cool wind, cool air from the pipe, and then cool the room. So we can use such geothermal energies. So what function, what role is being performed, and how does that do it? Why does it not do? So we can look at different kinds of, and then we can convert that into design principles. So nature does not have any waste, as you know. Does nature produce waste? What is the point you say, Savik? Yes, you're right. Nature has nothing like waste. What does it mean? How does it optimize energy use? Not a joule up more and not less. Because nature has exchange. It can dispense with or acquire. Both can be done. When autumn comes and when the rain is not there, the leaf shedding takes place, isn't it? When spring comes and rain is yet to come, the leaves start sprouting. So there are, as you know, there are two kinds of homeostasis: physiological and but the other one, physiological and at time and over time, so developmental homeostasis. So when we perspire, when we run and we perspire, and the perspiration makes our head cool, our body cooler, that is physiological homeostasis. And when we shed our teeth in the old age, because we can't digest, so the nature takes away our teeth. If you have teeth, you will eat more hard food. If you eat hard food, your body cannot digest it. So better take away the teeth. So there are, in nature, there are this kind of balancing forces which do this kind of adjustment. And I think it's something that we can learn from how one can organize heat exchange systems, energy efficient systems for creating cooling and heating both. Somebody mentioned about tube. What did you say about tube for the water? What did you say? Somebody from now I see a comment chat.
So the
yeah,
toothpaste tubes.
Huh?
So regarding the toothpaste tubes.
Yeah.
So basically, they developed it because the tubes that we use today, it is difficult to extract the entire quantity of toothpaste or medicine that is inside it. So they developed the inner structure of the tube to be like that of a lotus leaf, lotus petal.
So that can repel the remaining material.
Yes, sir. So that could be
okay.
easily.
Yeah, but one thing more that we need to understand is that nature, there are also natural functions. So functional food, for example, if the soil is rich in boron, then the crop grown in the boron-rich soil may have boron. So that's how we can find out food which, so if you have arthritic pain and you need boron, then you eat food grown on boron-rich soil, or you grow varieties which can extract more boron. So local varieties of maize extract 4 times more boron from the soil than hybrid maize. So then local varieties of maize become functional food. So what I'm saying is nature has diversity. Nature, if you look at different crops, different varieties, they extract different kinds of minerals from the soil. And many of the traditional crops were very rich in mobilizing these minerals. So they were more nutritively more richer. And that's the point that we need to pay attention to, as to how not only the forms and shapes of nature, but functions of nature can also be learned from, and we can develop modern foods, modern recipes, modern varieties for that matter, to see how they do that. We found, for example, we were doing a study of microbial diversity in the rhizosphere of different varieties of paddy in East India. My colleague Anamika today, she has a board meeting tomorrow, so she's not here today, Gyan's board meeting. So she found in a thesis that the traditional variety, which was still growing in the deep water conditions, had a very different microbial combination in their root, because they were transporting the nutrients from the rich clay that was there. They were low. When you say deep water, that means they are low-lying conditions. Low-lying conditions have more clay. More clay means more minerals. So the microorganisms must transport these minerals to the root, isn't it? And then plant will take it in the root. So this is very interesting, that how nature creates ecosystem for transportation of minerals from soil to the plant, plant to the grain, grain to our body. I mean, how did this happen? How did it select? Some of you might know that most of the traditional grain, wild varieties, have shattering property. Why would they have? Anybody? Any guess? Why do traditional wild relatives have shattering property? I'll come to your question just. Why do we have wild varieties which have shattering property? Shattering, you know, the pod will burst open and the seed will scatter. Can you guess why this function has been chosen by nature in the wild relatives? In the domesticated varieties, you can't afford to do shattering, because then you won't get yield. You have to harvest that. So you have high dormancy and you have grains are tightly bound. But in the wild varieties, when the grains mature, they burst open, because nature wanted to scatter the seeds for reproduction purposes. So now this domestication required us to select plants which were not shattering. And over the years, we have made crops where the shattering has been more or less stopped or delayed a great deal. Only when they over mature, they will shatter. So we can harvest them at a physiological maturity stage, then dry them, and then we can store them. So this entire food system would not have evolved if we hadn't looked for those mutations in the nature where they moved from shattering to selection. So human beings have interacted with natural variation all the time. Those of you who deal with natural variation would know that, and it's very important function. So I'll conclude by saying that our goal in understanding the natural variation should be not only forms and shapes, but also functions. And functions, not only what is visible to the eye, but also physiological and biochemical and molecular, of course, that many of you know. When I was doing a study, I mentioned, I think, to you about Oryza longistaminata, a wild relative of rice. It is the migrant from Timbuktu who knew about its property of disease tolerance, which Pamela Ronald then, as I told you earlier, cloned that gene XA21. But the people had this sense that there is a gene. They didn't know what the word gene, they knew the property, that this has a property which prevents it to get any disease. It doesn't spoil. So this is the kind of observations that people may have sometime, which may give us a clue as to why people deal with it in this manner that they are doing. And we can then possibly find its functions. I mean, you all know banana flower, the properties of banana flower. One of you have written a small proposal on that. Now, let me close by making 2 or 3 statements. One, some of you wrote that note. I have sent you a mail to few of you, only a few of you, but I have not sent mail to more only any one of you or all of you, whenever you get time, no rush in the next 3 months, if you want to expand the traditional knowledge that you documented into an article with photograph of your grandmother, grandfather, or whosoever, we'll be very happy to publish it with the photograph of the elderly colleague who shared this knowledge with you, with the scientific annotation, so that this is a tribute we can pay to our elders. And we will acknowledge them, we will take their consent before publishing. So all of you should consider that option. We can bring out a special issue of scholars learn from their grandparents, something of that kind, learning from grandparents, or intergenerational knowledge transfer in CSIR PhD students, why not? So I'll be very happy to bring out a special issue of Honeybee, consider that. Second, the question that has been asked about presentation. You can present it to your lab, I don't care. I mean, that obviously you will have to do, you can do that, but also submit here. That's all we're saying, because then we can see what patterns emerge and how can these projects be used for inspiring others in future and also enrich our presentations in the class. So any other question if you have before we close? Any other doubt, any other question? So next class, do think about creative ways, creative incentives. We will also see a film, what motivates us, and think of various creative incentives which will bring the best in us. So be creative, be innovative in identifying those things that can motivate you to bring out the best. Thank you so much. Good luck. Good luck. Bye-bye.
Thank you, sir.
Bye-bye.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.